Welcome back to my series on being an applied statistician in JAMOVI. In this video, we're going to be dealing with the chi-square goodness of fit test. And this is the first nominal data test that we're going to deal with in this particular series. As always, let's first situate this within the statistical decision tree. So you'll notice that actually the chi-square appears twice, once under a test of difference and once under a test of association. The one we're dealing with today is actually a test of difference, and it's the goodness of fit chi-square test. So let's just look at a few things. So it is a test of difference. It's when we have nominal data, nominal categorical data, and categorical data has a few special qualities to it. In particular, we tend to deal with it as count data or frequency data. And the test we use when we have a question of difference, when we have normal data, is the chi-square test, goodness of fit. Okay, let's look at an example of a research question which deals with the chi-square goodness of fit test. To what degree do students with different language groups, English, Spanish, and Korean, visit the writing center? That's just a descriptive question, right? So we have different language groups, people in the university who speak Spanish, English, and Korean at their home, and we're just interested in who's visiting the writing center. But we have a different question which is tied to that. Are students from different language groups who visit the writing center equal to or different from the proportions of these students in the university? A different way of asking this question would be whether the writing center serves the members of the university community who need writing instruction in an equal manner, or is it different from the proportions? So it helps give some sort of understanding of the nature of who is visiting the writing center. Let's do some question analysis. First of all, for the grouping variable, we have language groups. We have 3 language groups in this case, English, Spanish, and Korean. Number of groups is 1. The outcome variable is 1 language group. And what type of data is this? Well, this is nominal data with 3 different levels, English, Spanish, and Korean. So what do we need? We need a test that tests the proportion of levels of a nominal variable in relation to known proportions. So the levels of the variable is the counts of the English, Spanish, and Korean students who visit the writing center. What's the known proportion? Well, that's the proportion of these types of students within the university setting. Before we enter into an analysis of the test and how we do this test, let's just remind ourselves first, though, just a little bit about nominal data and how nominal data works. So nominal data is naming data. It consists of frequency of participants organized into distinct categories. So let's say I have a language group variable. That's a nominal variable. It has 3 levels, English, Spanish, and Korean. And I would count the number of English speakers in that group, Spanish speakers in that group, and Korean speakers in that group. Nominal data is not measured or ordered. It just consists of counts of participants into one category or the other. This is very important for the chi-square test, goodness of fit test. In nominal data, the categories are discrete and cannot overlap. In other words, you're either in one category or you're in another category. You cannot be in both categories unless you have a category which is called both categories. Also, for our purposes, it's interesting to note that qualitative coded data can be nominal data that you can use in tests like a chi-square. Okay, let's enter into a schematic analysis of this test. So there are actually 2 versions of this test. One version, which we're going to call the equal proportions version, has a very simple assumption. So as we already know, we have some nominal variable, and we've observed, in the different levels, level 1, 2, and 3, certain counts of people. So let's say this is English, this is Spanish, this is Korean, and I've counted how many people come to the writing center who are English speakers, how many people come to the center who are Spanish speakers, and how many people who come to the center are Korean speakers. The equal proportions goodness of fit test compares it to the idea that we should think that there should be equal proportions of students. There should be equal proportions of English speakers, Korean speakers, and Spanish speakers who come to the center. So basically, you're comparing an observed count to an equality, a random assumption of equality. This is useful in some cases. On the whole, I don't find this a particularly useful test, mainly because for most human educational research, I never have the assumption that things are equally distributed in a particular setting or particular educational setting. I'm assuming actually that there is some difference in the proportions. For example, in an American university in, say, a rural area, I might expect to find far more English speakers than I find, for instance, Korean speakers. Okay, let's look at a second version of this. This is the same test, a chi-square goodness of fit test. However, this is when you have known proportions. So let's take a look at this. So what I'm comparing is the counts I have in each of these different levels to some expected known count. So let's take a very simple example, the one we're dealing with. So let's say I'm interested in people, language speakers who visit the writing center. I count how many English speakers they are, and I compare it to the known proportion of English speakers at the university. I count how many Spanish speakers they are, and I compare it to the known proportion of Spanish speakers at the university. I count how many Korean speakers and I compare it to the known proportion of Korean speakers at the university. This is a far more useful test because basically what it's telling me is whether the setting where I am counting the frequencies is parallel, is equal to, or different from the known proportions. Okay, so when do you use the chi-square goodness of fit test? First, when you have a nominal categorical variable and one nominal categorical variable, and you want to know if the counts proportion of the variables are systematically different from a random distribution or a prior known distribution. Data consists of one nominal variable and a frequency count, number of people in each category. A key assumption of the chi-square test is independent is that each subject contributes to only one category. This is important. You cannot have categories with 0 in them, and you need at least 5 people in each category and subcategory. And with that, I suggest we go over to JAMOVI and see how to perform this particular test. So as you can see, I have opened up JAMOVI and I'm in the data window. And as you can see, I have one variable here. Let's just double click on this and see what this is. So this is language group. This is the language spoken at home. And these are the people who actually came to visit the writing center. I have 3 levels, English, Spanish, and Korean. Remember, this is language spoken at home. And this is a nominal variable or categorical variable. Okay, so the first thing I want to do, I want to go over to analyses. I want to go over to exploration, into descriptives. I'm going to get rid of, I'm going to get rid of mean, median, all these statistics. I don't need them. But what I do need is a frequency table. So I'm going to click on that. And I do need the n, the size of the sample, and it's always useful to know if I have any missing data. So let me take language group, let me pass it over into variables, and let's see what I have here. So I have 50 people in this group. That's important because I need to report that later on. And then I have certain proportions here. I have 25 English speakers, 18 Spanish speakers, and 7 Korean speakers. So the English speakers make up 50% of the group, the Spanish speakers make up 36% of the group, and the Korean speakers make up 14% of the group. So this just tells me who's visiting the writing center from which language groups. Now, let's do a chi-square goodness of fit test. So let's click on frequencies. Let's go down to N outcomes goodness of fit test. Let's just click on that. Okay, so let's move this over here to the variable. And let me just click on this expected counts. Now the expected counts, if you look over here in this table, that's when I have an assumption of equal distribution. So if you look under expected, you can see that the proportion is 0.33. The proportion for Spanish speakers is 0.33. The proportion for Korean speakers is 0.33. In other words, in this test, we're looking at the observed observations and we're comparing it to this idea that all groups should be equal. That's fine. We do have a significant difference here, but I don't think that's particularly useful because actually within the university, I don't really assume that I have equal proportions of students at the university. It's not that at the university I have 33% English speakers, 33% Spanish speakers, and 33% Korean speakers. If I click on this, expected proportions, it opens up this particular dialog box where it says English, Spanish, and Korean. Those are the levels. And at this point, I can actually enter the proportions that actually exist in the university. So I happen to know that 75% of students are English speakers, 20% of students are Spanish speakers, and 4% are Korean speakers. So now I have a particular set of ratios. If I go back to my proportion test, what am I comparing? I'm comparing the observed count to the proportional count. Now, if 75% of the students at the university are English speakers, I would expect that 39 students would be coming to the writing center. 39 English speaking students be coming to the writing center. How many are actually coming? 25. Based on 20% of the population being Spanish speakers, how many students would I expect to come to the writing center? Well, I would expect 10 students to come. How many are coming? 18 are coming. Based on the 4% Korean speakers in the university, I'd only expect half a student, well, let's say one student to come. How many are actually coming? Well, 7 students are coming. In other words, my English-speaking population is coming less than I would expect, but my Spanish and Korean-speaking populations are coming more than I would expect, just based on proportions of students. When I look at the statistic, this is a statistical difference. There's a statistical difference between the observed and the expected. In other words, there's a different proportion of students coming to the writing center from the different language groups than I would expect based on the proportions within the population. This is significant at the 0.001 level, so it's very significant. And with that, the only thing left to do is to actually report this particular test. So let's read through how to report the chi-square goodness of fit test. I'm just going to read through the text, and you can already see the arrows which point to the different tables that you can use from the JAMOVI data output. A chi-square goodness of fit test was performed to examine whether the students from different language groups who visit the writing center is equal to the proportions of these students in the university. The proportion of students from the various language groups who visited the writing center differed significantly from the general proportions of language speakers at the university. You report the degrees of freedom, that's the 2. You report the sample size, which is 50, You then report the chi-square, which looks like an X with a squared 2 at the top, but actually is a letter chi-square. And then you report the significance level, which in this case is 0.001, so a very high level of significance. Since there is a significant difference, it is worthwhile pointing out what the difference is. You don't have to necessarily give the proportions, you might, but you don't necessarily have to. I would probably present the proportion test table, right, because I think it's useful. But I would report it. Fewer English speakers than expected visited the writing center, while more than expected Spanish and Korean speakers visited the center. As always, I hope this has been a useful video for you. I hope this helps you move forward with your research, and I look forward in seeing you at our next video.